Welcome to this lecture about building information modeling for project managers, or BIM. I'm Ralph Montague, and just to give you a bit of background, I'm an architect by profession, a director at ArcDocs BIM Consultants, and for the past 10 years we've been specializing in this area of information management and BIM, and been helping project teams and companies and people to embrace this digital way of working. We've had a number of roles on various industry groups, and hopefully we can share some of that experience with you today. This lecture will focus on the broad subject of ICT for project managers, which is of course information and communication technologies. More specifically, we're going to be talking about information related to the built environment and how we produce and communicate that information or share that information, and the technologies that we use to do that, which in this case is building information modeling, which is both a process and technology for digitizing and organizing information for the built environment. This comes under an ISO standard for information management using BIM, ISO 19650, which we'll be covering in this lecture. The important question is to ask, why do project managers need to be engaged with this subject, and what do they need information for? And of course, information is there to help manage expectations, objectives, costs and processes on projects and try and improve the outcomes, to easily identify and understand problems and communicate solutions to those problems, to analyze any risks and opportunities that present on projects and deal with those, to effectively communicate with the various stakeholders on projects, which would help get timely decisions to avoid any potential delays or late changes, and also to help impact on some of the major challenges that we face in the construction industry, such as building economics. It's true that buildings in the way we do things at the moment are too costly and they're too slow to produce, and it means that we're not meeting the demand. The building performance, which obviously affects the environmental costs. Buildings are responsible for something like 40% of the CO2 emissions, so we have to improve the way we construct to produce better performing buildings, and even to consider how we upgrade our existing building stock. And then we're looking at building quality and compliance with regulations and standards and safety legislation to avoid any personal loss of life or damage. And then looking at some of the issues we have in procurement, which can be quite administrative heavy, and lots of delays and variations and disputes that occur, which are not adding any value to the building process. So with these ideas in mind, I want to refer to this quote from Albert Einstein, which I think is very good. And he basically says that when we look at these things and solving some of these challenges in the construction industry, we need to be looking at them in a new light, not using the same thinking that we've used for the past 50, 100 years. This is where the digital approach and using ICT can help. So why is this subject important for project managers? This is a picture of Dublin. It's the city I live in. And what you see in this picture is the built environment. The B in BIM, or Building Information Modeling, stands for the built environment. So it's not just vertical buildings, but it's everything you see in that picture. It's the roads, the bridges, the waterways, the utility networks, everything that supports the way our society functions. And it's important to everybody that lives in this city. It's where we live, it's where we work, it's where our children go to school. So the built environment is really the fabric of our society, and if you have a good performing built environment that supports society, that's good. But it's true to say that we have some challenges even in Ireland, where we might consider ourselves a first world country, but we are unable to deliver enough housing, enough education facilities, enough healthcare facilities, enough infrastructure. So even in Ireland, the built environment is being challenged. Now, behind what you see in this picture of physical infrastructure, there is information information that describes how this built environment is to be constructed, and information that describes how this built environment needs to be maintained and operated. And in fact, under health and safety legislation, every building you see in that picture is required to have a building record, a record of information of how it was constructed and information that describes how it should be safely maintained and operated through its life cycle. So information is really key to how the built environment functions. So that brings us on to what we're discussing today, and that's the information, or the I in BIM. What you see in this picture is what's called a safety file, or an building record, or an operations and maintenance manual. At the end of construction, under the health and safety legislation, the contractor and the designers are required to hand over to the building owner a copy of all the information that describes how the building was constructed and how it is to be maintained and operated. Obviously, this is a poor example, but this just demonstrates how our industry has functioned over many, many years using paper-based documentation. Even though for the last 20, 30 years we've been using computers in doing our work and digital technologies, at the point of exchange of information, we tend to print that off, put it in a binder, put it in a box, and hand it over, or save it as a PDF document and put it on a DVD, or put it in a folder within a file structure. But both those examples really mean that we're locking the information in a static format that's difficult to use, difficult to query, difficult to find, almost impossible to keep up to date because it's in a static format. So you might question, well, is this a problem? I mean, we've been building this way for hundreds of years, thousands of years. This particular building that we're looking at was constructed using this type of information, and it is currently being maintained and operated. So some people might feel that using paper-based documentation isn't a problem. I suppose when you look at this picture and you sort of imagine that you might need to find something of importance to interact with this building, it would be pretty difficult. So there's an excellent study done in 2016 by the Boston Consulting Group, who consult to the World Economic Forum, and they determined that working with this analog type of information is adding about 13 to 21% to the cost in design and construction phase of assets, and about 10 to 17% of the costs every year in the operational phase of assets. So while it is entirely possible to construct and maintain and operate buildings with paper-based documentation, it's costly, and it's so it's slowing things down, and it's adding to the financial cost of building assets. So that's really what we're going to be talking about today, is looking at this comparison between paper-based information and digital information, and how that might work. The M in BIM, or modeling, describes an alternative to working with paper-based information. So it is entirely possible today to construct within software a virtual representation of a physical building or piece of infrastructure. And within this digital model, all the components that you see that make up this model are objects which contain digital information about that component, recorded as structured digital data that can be used and accessed and queried, etc. It's very important to note that this is an alternative way of working to paper-based information, and that whatever you want to call this digital model, whether you want to call it a digital twin, or project information model during the capital delivery phase, or asset information model during the operational phase, it is a digital representation of a physical building. The problem I find with the acronym BIM and the word building information modeling is this word modeling, because most people would look at that word and say, well, that's not something I do. As a project manager, I don't do modeling. As a quantity surveyor, as a financial accountant, as a solicitor, so this has obviously got nothing to do with me. Meanwhile, everybody is engaged with the building environment. What might be a better word is management. That this is a way of managing the information about the built environment in a digital way. Because if you called it management, then everybody would identify with this. But of course, the acronym BIM and Building Information Modeling has been around for a long time, over 15 years. So we're not going to change the word. But if it helps everybody in their own minds to identify with this process, this digital process, then by all means change the word. What you're seeing in this short video, for anybody who hasn't seen a building information model, is a digital representation of a building. So you can look around this building, you can slice and dice the view that you're looking at, you can zoom in, zoom out, you can click on the various components that make up the building, you can get information about them. For instance, if you just look at that door in the corner of the building and we clicked on that, on the right hand side, I appreciate it's very small, but you can see all the information about that door can be recorded in this environment. All the materials being used, the fire rating, the acoustic rating. So as you're making design decisions about elements of the buildings, you can record those decisions right in that dialogue connected to the object. And that includes the materials and things that make up primary elements of the building, such as walls and floors and roofs, which are not sort of components, but they're elements that are constructed on site. What you're seeing now in this view is what looks like a traditional plan in the bottom left, a traditional elevation in the top right, the 3D model in the top left, and a schedule of information in the bottom right. So the important thing to grasp here is that you're not looking at separate documents, that it's the same information being presented in a different way. So the information is only input into this digital model once, but it can be viewed in multiple ways that suit your workflow. You can see there that in the plan view we're adding a new door, and that door automatically appears in the elevation view, in the 3D model, in the schedule. So everything is connected and to the one model. So if you're making changes or you require changes, you only have to make those changes once, and those changes are reflected in whatever view type that you want to interact with. If you make an edit, let's say if you move that door, you'll see that that door moves in every view. So all these different views, which traditionally would have been drafted independently and would have to be maintained and updated independently, are all being driven off the single building information model in this instance. As you make design decisions, as I said earlier, you can record those decisions directly within this environment and keep adding information as you go through each stage. So you're collecting more and more information about that door or any component of the building. You can also create these detailed call-out views. Again, these are just views of the same model, and within these call-out views you can add additional notes or annotation or even overlay a bit more detail to communicate with people what needs to happen in that instance. But the underlying detail is being driven from the main model, and so you can absolutely go right down to very detailed drawing representations that are generated from this building information model. Let's say you needed a new section somewhere just to have a look at something. You simply draw a section line through the model and it automatically generates a new section. So nobody has to draw this new view. It's produced by the model itself, and you can choose to display that section in color or 3D or black and white. It doesn't really matter. It's just a way of looking at the information. whether you want to orientate it. If you're sitting in a meeting and you want to sort of create a better understanding for everybody, you can simply reorientate that view, and everybody immediately can see and understand the issue that you're trying to discuss. Something like that clash between the beam and the piece of ductwork would have been quite difficult to visualize in 2 dimensions, but suddenly everybody fully understands what the problem is and what action is required to resolve that problem. You can drop a camera view into any space or room, and it immediately creates a 3-dimensional view of that space that you can look around in. So if you're having a discussion with an engineer about that particular plant room, and you're trying to resolve an issue, you can do that straight away in a meeting. It takes seconds to create these views. You can do the same thing with the external view of the building. Just drop a camera and create a view which you could then reorientate and look around. So the thing about this is the 3 dimensions. Everybody understands 3-dimensional views very quickly. Very few people can understand 2-dimensional drawings. So, and you can choose to render those views up. The rendering takes a little bit more time, but you can get these photorealistic quality views that you can communicate with planners, clients, other stakeholders, etc. So I want to take the discussion now toward talking about efficiency and productivity in the way we do things in the construction industry. The reason is there's been many studies to show that productivity in construction hasn't changed very much in the last 40 years. So we don't produce, for the amount of labor input, we don't produce more output than we did 40 years ago. And that's creating an issue because obviously buildings are very slow to produce, very costly to produce, and we're being challenged by not keeping up with the demand of a growing population and an urbanizing population. If you look at other sectors, such as manufacturing, just as an example, productivity has more than doubled in the past 40 years. So that means in manufacturing, they're producing twice as many cars, twice as many aeroplanes, twice as many computers, and consequently the price of everything is coming down. It's more affordable to everybody, but we can't say that for construction. So productivity is an issue in construction, and it's related to efficiency in the way we do things. So as a exercise to look at how they produce information and manage information in manufacturing versus construction, and I do appreciate manufacturing isn't construction, but I think we can definitely learn something from the manufacturing industry. In the design phase in manufacturing, they construct this virtual model or digital version of the thing they're going to build in software. So they work out how all the component parts are going to come together then, and they resolve that as much as they can in that digital environment where it's easier and cheaper to deal with issues. And then when they go to the procurement phase, since they've worked out all the individual components that are going to make up that car, they can go and procure those parts from anywhere around the world. They don't have to make all the parts in the same factory. They simply have to procure the parts, bring them together, and then when it comes to construction on the assembly line, they assemble that car exactly the way they've designed it. And I think that's probably the biggest thing we can learn from the manufacturing is that they don't make changes on the assembly line. They don't start moving stuff around because they don't know how that change is going to affect other people down the line. And because they construct physically exactly what they've designed in the digital model, when it comes to the physical item, it means that they have a digital twin of that thing. They have a digital version which contains all the information about every part, which is why you can walk into a spares shop anywhere in the world and say, I've got this car and I need this part. They can go on a computer and look it up, and in seconds they can tell you where that part is, how much is in stock, etc. As a counterpoint, let's look at the way we do things in construction. So in the design phase in construction, we don't actually work out exactly what we want to build. So we produce some documentation which describes the design intent. In other words, It describes more or less what we want to build, but we feel there's enough information there to get a price from someone. At the procurement phase, since everything isn't fully resolved and fully coordinated, really what's happening is that the contractors are, are pricing and procuring a package of work at risk. So in other words, they're looking at the design intent information and they're making a call. They say, yes, we believe we can develop that further and we can and ultimately construct this thing. So where the information is getting resolved and tested is really on site. Yeah, so people working really hard to catch up with the actual physical construction process and often making changes within that physical building environment, which is actually the most expensive and dangerous place to begin to make changes, because often people making changes don't realize how that change is going to impact others that are coming after them. But also from a information management point of view, since so much is happening on site and is probably not being captured as to what was actually built, when the information that we have at the end is really just a mixture of design intent information, or maybe design intent information overlaid with some red line markups to say what has or hasn't changed, some fabrication information. So it's a whole mix of information that doesn't really describe or capture what was actually being built on site. But that's not to say construction doesn't work. Obviously, we do build buildings and they do eventually get built. It's just saying that the information that we receive at the end is not exactly a digital twin. What's interesting, if you're looking at this from an efficiency and productivity point of view, is effectively the manufacturing industry builds things twice. So they construct this product within the digital environment and they work it out as much as possible within that environment rather than the physical environment, and then they construct it a second time on the assembly line, and that's why you end up with this digital twin. Whereas in construction, we're really just going through a process of constructing the thing once. It's a progressive development of design intent information to construction fabrication information and ultimately what gets constructed on site. And instinctively you might think that building something once is more efficient than building it twice. But when you look at the way these two processes work, I think the thing we can learn from manufacturing is that it's actually more efficient to build it twice, to build it as far as possible within this digital environment where you're not committing real materials and real labor. Try and work it out as much as you can in the design phase, and then execute the construction exactly according to the digital model. Staying on this theme of productivity and efficiency, but looking specifically in the way we produce and manage information in the construction industry. The traditional way of producing information, in other words, not using BIM, is to use several ways to describe the building or piece of infrastructure. Two-dimensional drawings like plans, elevations, sections, details, schedules, specifications, etc. This is what we've been doing for hundreds of years, so obviously we all understand this. The problem with this way of working is that each of these ways of describing the building are manually produced, so there's a high potential for inconsistencies and errors between these different documents, and of course those inconsistencies and errors turn into requests for information or delays or even potential rework or abortive work on site. So we're all aware of those things that occur at the moment. The approach with BIM is more like manufacturing, where we describe the building or the piece of infrastructure once within this digital model. So at the heart of the BIM process are the objects or the components that make up the building, and the information about every component is digitally recorded within the component itself. Those components are then assembled within the building, the virtual building, So you're literally constructing the building within software, and because every object has a spatial presence, it can, the software can find if objects are clashing with each other, so the coordination becomes very easy. Those objects can be connected to a construction program, so the sequence of construction can be considered, and that means you can look at issues such as logistics and health and safety. Since every object knows what it is, the software can easily count those objects and get quantities, areas, volumes, etc. And that helps cost control. And we can even analyze these models in a real world environment. So we can connect it to weather data and geographic data and test for energy performance or structural performance to optimize the design. Once that model has been constructed, the model is then used to generate the output drawing. So nobody's drawing drawings anymore, typing out schedules. The information within the model is used to generate those views. So when you look at these two ways of working side by side, you might say, well, the outcome is more or less the same. We have this set of documentation, but there's two very important differences. One is the amount of effort that goes in to the first way of working, where you're describing the building several times through all this documentation with a manual effort to produce all those different documents, compared to just describing the building once and then letting the model generate all the outcomes, is obviously vastly different. But then the second big difference is in the BIM process, all the documents and schedules, etc., are being generated from the same model. So it's reducing all the inconsistencies and errors that would eventually turn into RFIs and delays and disputes and rework and abortive work, etc. So there are, while the output might look the same, there are two very different ways of working. I think that's important for project managers to understand. But I want to tell you about a third way of working, and unfortunately, this is very prevalent in the industry. This is what I call pseudo BIM. That's often occurs where a client is saying, I'd like to use this BIM process on my project because I believe it's going to save a lot of time and money. And what people do is they just go off and do what they always did. In other words, they go and produce like separate drawings and details and schedules, and they describe the building in the way they always did. And then, in addition to that, they have someone in the office who takes all those drawings and tries to convert it into a building information model. The problem with this way of working is there's no connection between the output documents and the model. So those drawings are not being generated from the model. Those schedules are not being generated from the model. So the problem still exists of all the inconsistencies and errors. So all you've done is you've taken the old traditional process and you've just added an additional workflow, but which has very little value because there's no connection between the two. So looking at these three ways of working side by side, and if you said, well, which way is the most efficient, most productive way of doing things, especially when you consider the amount of original effort that has to go in to produce the information, and also the effort to make changes. So, within the BIM process, if you need to make a change, you simply make the change once in the model and you regenerate all the drawings and schedules. Whereas in the process that doesn't use BIM, you have to go and make that change in all the individual documents. And then the management around that. So if you know as a manager that all these documents are being produced separately, then there's a lot of checking and cross-checking to make sure they do try and describe the building in a consistent way. Whereas if you know that the information is being produced from a single model, then all you have to do is check the single model and also the accuracy of information. So when you consider all these things side by side, you have to conclude that building information modeling as a way of working is the most efficient, most productive way of producing and managing information, because you're only creating the information once. Obviously, not using BIM at all, just going back to the traditional way of describing buildings through drawings and details, etc., is the next productive, but the least productive, least efficient way is to do pseudo BIM. To describe things in the normal way, and then in addition talk about adding a model to that process. So this is very important for project managers to understand, because what's happening a lot out in industry is this pseudo BIM, because people think nobody realizes that this is the way they're working. But it's very obvious when you're sitting in a meeting and somebody comes to a meeting with a whole set of drawings, and you ask them, well, where's the model? And they say, well, the model will be ready next week. That really indicates that they're using a pseudo BIM process, and they've just added time and added cost to the project without getting any real value. A little bit of terminology now, and again, this is important for project managers to understand. When you're sitting in meetings and people are discussing BIM and they're using these terms that have become known over the last couple of years, you should know what they mean. So one of the first things you'll hear is people talking about level 2 BIM. And what level 2 BIM is describing is a level of maturity adoption of BIM. So if you weren't doing any BIM at all, that would be level 0. If you were doing some of the work in BIM, some of the work in this process of creating a virtual model, but then beside that you were doing some traditional two-dimensional drafting and typing schedules, etc., that would be level 1 in terms of adoption and applying some of the standards. Level 2 means that everybody is working in this BIM process that I've described, but they're doing it in separate models. So every discipline or every supplier that produces their information is producing it within a separate model. And you might say, well, what's the point of that? If we just trying to build a single building, shouldn't we all just be working in the same model? Well, that would be the future, where and what they describe as level 3 is an integrated model, but we're not there yet. So at the moment, the best we can do is for everybody to use BIM, but to use it within separate models. And the reason for that is to do with the contracts and the PI insurance that we have in the industry. There's no PI insurance that would cover people working on the same information. So to keep clear lines of responsibility and liability, we have to keep people working within their own models. But you can merge these models together in what's called the federated model. So that's a new term that everybody needs to understand. The federated model looks like one building model, but when you peel it back, it's actually a collection of models that have been brought together. In this federated model environment, we can do some really interesting things that we couldn't do before in terms of coordination and resolution of problems, because every object in these different models has a spatial presence. The software can find where objects are clashing with each other. So what's called clash detection is really just an analysis of these models through software that finds problems, and I'll show you a video about that in a few seconds. But we can also do other things which we couldn't do before. So we can connect all these objects within these various models to the construction program and start looking at the sequence and the logistics. So what people are calling 4D BIM is really the fourth dimension being time connected to the objects. And in this environment, you can look at the sequence of construction. You can look at logistics such as delivery, site setup, temporary works, health and safety, fascinating things which were very difficult to do before. We can also do, as we said earlier, cost quantity takeoffs. So in other words, since every object within these models knows what it is, we can easily count them, cost them, and what people are calling 5D BIM. So 5D BIM is really about cost control and working with quantity surveyors who understand how to extract quantities from these models and get more accurate costs. We can also, as we spoke about earlier, analyze these models from an energy performance point of view, from a structural performance point of view. And the purpose of this analysis is to try and optimize the design and create buildings that are going to perform better once they are constructed, so and understand how they're going to perform. And so people are calling that 6D BIM, is about analysis and sustainability. And the last part is, since we have this data-rich digital model during construction, we can also populate that model with additional information that will be useful to the property and facility managers, such as warranties and maintenance periods, etc. So that sort of asset information model is what people are calling 7D BIM. So this is just important that you know what these terms mean when people are talking about them. When you're in meetings as a project manager, you're probably not going to be doing these things, so these will be done by other people, but at least you should know, what they're talking about. In this video, this is just showing the federation of the different models. So you can see the civils model and the structural model and the services model and eventually the architectural model coming together within this federated environment. So this, as I said, this looks like a complete building model, but actually it's a collection of models that have come together. But you can use this in meetings to walk around and discuss potential problems, give everybody a full understanding of what the building is and how it's going to work. And in this environment, you can do what's called clash detection. So clash detection is pretty easy. Basically, you have two windows and you decide what you want to analyze. So you could say, today at this meeting, we want to analyze structural steelwork versus mechanical ductwork. So you select the steelwork on the one side of the window, you select the mechanical ductwork on the other side of the window, make some settings and run a test. And what this does is the software, since every object within this model has spatial presence, it can give you a list of where these things are clashing and take you to a view to see the potential problem. Now, you can't make any changes in this environment, so all you can do is identify the problems and then assign that problem to somebody to deal with, but they've got to go back to their original models and fix the problem. It's very clear to everybody to understand that there's an issue. It's very quick to find these issues, and we can track how the progress of the resolution of these issues with this environment. So you can also decide if these are real issues. So maybe the software sees that as an issue, but we know that on site we'll make a hole through the beam and we can resolve that. So you can also accept issues so that the next time you do the clash test, it won't come up as a new issue again. So this is just a quick process, but everybody can leave the coordination meeting, the design coordination meeting, with a copy of this file with all the issues assigned to them. They can go back to their office, open their software, make the changes, and resubmit their model for the next meeting. You can also generate from this a report in various formats, which you can save for historic purposes. So if ever there was an issue later on and a dispute, at least you have a record of what was discussed on that day and who was meant to deal with the issue. This next part shows a connection with a construction program in Microsoft Project. So you can see a typical Gantt chart with a work breakdown structure and items in the timeline. Basically, you connect groups of elements to the items in the program, and then you can play through the program day by day, hour by hour, week by week, whatever, to see how this building is going to come together. Now, obviously, this is a very simple model, but you could have added the site setup, the scaffolding, the cranes, the deliveries, anything you want to look at the logistics of how you're going to construct this building over time. You can use this environment to communicate with people at the weekly meetings what's going to happen this week and the environment they're going to be working in, so they can understand what they're going to be doing. You can also track what's actually happened against what was planned to happen to monitor progress on site in a more visual way than looking at Gantt charts. So it's very useful. That's called the 4D BIM. To dig into this idea of the digital twin a bit further, really what we're talking about is digitizing and organizing the information about the built environment. So that's the first thing, is how do we organize information of complex building or infrastructure projects. The important thing is we need a common language or breakdown structure that everybody operates with. So we can take a city, which is a very complex built environment, and we can break a city down into districts or campuses or city blocks, or at the highest level, we can talk about complexes, and complexes are really collections of different entities, whether those are roads or buildings or parks or different built elements. The individual entities, which could be, the entity could be a building, it could be a road, it could be a park. So that would be the next level. So we can classify and organize things at the entity level. Entities then can be broken down into various elements, primary elements. So a building, for instance, the primary elements would be substructure, the structure, the external facade, the walls, windows. The primary elements then can be broken down further into systems. So in this instance, a ventilation service can be broken down into a number of different systems, one of them being the mechanical extract ventilation system. And ultimately, the system can be broken down into individual products or components or materials that make up that system. So in this instance, an air handling unit. So at the smallest scale, when we talk about organizing and digitizing information, we can think of an individual product or material, and then we can think about how that is connected to a system, to an element, to an entity, and ultimately to a complex. And that's a common way of breaking down and organizing information about buildings and construction. We can also add some common language around non-physical things, so activities and spaces. Spaces are defined obviously by different building elements, but the space itself is not a physical entity, but we can begin to classify types of spaces and then talk about the activities that occur within either the complex or the entity or the space. And on the other end, with products and systems, we can talk about the tools and equipment required to either produce or maintain those elements. So tools and equipment are normally not permanent features of the built environment, but are necessary parts of putting it together and maintaining it. And what I've shown you in this slide is what is called Uniclass. Uniclass is a unified classification system that was developed in the UK. It's the UK's implementation of ISO 12006, which is a dictionary for classifying everything in the construction sector. So a common language that we can all begin to use to organize and structure the information that we produce. There's two parts to it. There's a machine readable part. In other words, there's a code, and then there's a human description, human readable, human understandable part. So if anybody wants to find out more about Uniclass, you can go to the Uniclass website, which is over there, and read more about it. But it's an easy way of trying to take complex built structures and break them down into something that we can deal with. So if I just take that air handling unit as one example, because if you can understand how this digital process works for one product, then you can understand how it works for systems, entities, elements, etc. So we understand physical elements. The digital version of a physical element would contain a number of things. The first thing is there would be a graphical object that represents that thing. And the object is important because this graphical object in the digital model tells you things about the size, the geometry, the location of that thing in space. So it has a physical presence. It also tells you about the connection points. So those could be physical connection fixing points to the structure. They could be connections to other services, mechanical, electrical services, etc. And that's all described through geometry or graphical data through an object. So remember I said earlier that the object is at the core of the BIM process. But we also need to know things about this object. And we want this stored as structured digital data that we can search on, find, query, use. So let's just call that non-graphical data that is connected to this object. And lastly, we can't forget about documentation. So we do need to have certain documentation available about this element. In order to sell this element in Ireland or use it, it needs a CE mark, it needs a declaration of performance, it would have had to have undergone extensive testing and certification, so you need copies of tests and certificates, installation, commissioning certificates, operator's manual, etc. These kind of documentation, won't be serialized as digital data, but you do need to find and get to these documents pretty quickly when you're looking for them. So the digital version of the physical asset is these three types of data. And I think that's important to understand, because a lot of people think building information modeling is just about 3D models, but it's not. It's about all this information. And these three types of information will be stored in what's called the common data environment, a digital repository of information about the building or piece of infrastructure. What connects these three types of information is a common classification system that we just spoke about earlier, the UniClass. So every air handling unit in the building and in the city should have this UniClass classification code that connects the object to the data to the documents. If you've used BIM correctly, then you can still have drawings, but nobody has to draft those drawings. So there's enough geometry within the object to generate the drawings. There's also enough non-graphical data within the attributes or properties of that object to generate any notes on drawings. So nobody has to type the notes on the drawings. Nobody has to type out schedules anymore, because there's enough information within the non-graphical data to generate any type of schedule you might like to use. So drawings and schedules are really just outputs that people may want at times from the data. And we can do all these things we spoke about in the previous slide, all this fascinating 3D coordination, clash detection, sequencing, quantity extraction, because every object is classified, knows what it is, has the right data attached to it. So that's how the digital environment looks, for every physical product, every system, every element, every entity within the project, if you're using BIM. If you're not using BIM, well then of course we don't have any objects anymore, so we don't, we have lots of drawings that people have manually drafted, we have lots of schedules which people have manually typed out, we can still have lots of documents which people have collected together, sort of PDF documents, but we'll end up without BIM back in the situation where at the end the building record is something that is difficult to search, difficult to query, difficult to use, and that's the opposite of a digital twin. From a project manager's point of view, it's very important to step back and ask, what do the clients want? What do the employers, the building owners, the developers want? What I can tell you is they don't want BIM. They're not asking for BIM. They're asking for a building to be designed and constructed. And what's important to clients is to understand what they're going to get. What's the scope of the building? Is it going to suit their needs? Is it going to suit their image? Obviously, they want to know when they're going to get it, and time is important. Cost is always an issue, and knowing how much it's going to cost. Quality is an issue. How long is this building going to last? How often do we have to replace things? How much is it going to cost us to maintain and operate this building? So these are quality issues. Are we getting value for money? Clients are interested in knowing whether they, getting the best value for money in the significant investments that they make into the built infrastructure. And I think this is probably one of the most important questions clients have is, are our risks going to be effectively managed? For most clients, building is not their core business. If you're a banker or a retailer or whatever, like banking is your business, retailing is your business, not building. And what I can tell you is for most clients, building a building is probably one of the worst things you'll do in your life. It's fraught with problems. You end up not getting what you wanted, not getting it when you wanted it. There'll always be delays, not getting it, for what you want to do, pay for it. There's going to always be cost overruns. The quality will be diminished. You'll be forced to accept less than you wanted. It may not perform as well as you expected it to perform. Clients are hiring professionals and project managers to manage these things on their behalf. And you might say, well, if that's what clients want, what's this got to do with information management and BIM? What I can tell you is the first element there, the scope, the fact that the three-dimensional aspect of BIM, the fact that you can look around this building, walk around this building before it's ever constructed, and let everybody fully understand and appreciate what it is they're getting, helps the clients understand the scope. The 4D BIM of testing the logistics of construction over time and how the building is going to come together, and the logistics and the health and safety is helping everybody to understand the time. The 5D BIM of quantity extraction and getting a better handle on costs gives everybody a much better understanding of the costs. All the analysis we spoke about, 6D BIM, energy analysis, structural analysis, optimizing the design for performance, gives everybody a much better understanding of the quality. And the last aspect, the 7D BIM of presenting at the end of a project to the client a digital version of their building or piece of infrastructure with all the information they need to maintain and operate this in a digital structured format is also a quality issue in my opinion. Instead of giving them a room in the basement with lots of boxes and lever arch files, something that's going to actually make a huge difference in the way they maintain and operate. So you can see that BIM touches on everything that's important to clients, but they're not specifically going out to the market and asking for BIM. They're asking for the other things, and that's important for project managers to connect the dots between what information management and BIM is going to bring to these important things for the clients, because ultimately clients want better buildings built quicker and built cheaper. And most people think you can't have all those three things. Like if you want something better, you have to spend more money or spend more time. And that is true if you think of that in the context of the way we do things now. So the process is what it is. So in order to change one of those variables, you have to give up one. But what if we could change the process? And this comes back to the first quote that I had at the beginning of the lecture. What Albert Einstein was saying is, you can't solve things if you within the thinking that you've always had. So what if we could change the process? What if we could be better at the way we do things? What if we could eliminate some of the wasteful way in which we produce and manage information and become more efficient and more productive? And then possibly we could meet all these demands that clients want. For instance, the Lean Construction Institute have said that over 30% of the cost of construction is waste. So money spent on things that add no value to the building itself, things like duplication of work, abortive work, rework, wasted materials, delays, disputes, even litigation. None of those things actually adds material value to the building, and yet we're spending a lot of money and a lot of time on those things. So if we could eliminate some of those things and put some of the money back into more quality, etc., maybe clients can get these three things. It's interesting when you look at the UK government's construction strategy targets for 2025, this is what they're aiming for. They want to build buildings 50% quicker, 33% cheaper, and 50% better. And by 50% better, they mean 50% less carbon. I mentioned earlier that the built environment is responsible for something like 40% of the carbon emissions. We've got a huge climate problem on our hands, and the construction industry, the main contributors to that. So obviously in the UK government's mind, we can get all three things. We can get quicker, better, cheaper, and whether you agree with those targets or not, what I can say is if our UK counterparts are working towards those targets and we're not, then at some point in time we will become uncompetitive in a global market and not able to deliver even construction within our own country. So this is a global issue. The World Economic Forum is writing and thinking and talking about this issue of construction. The world populations are growing, people are urbanizing to cities, cities are growing. There's an enormous strain on infrastructure for housing, healthcare, education, all around the world, even within our own country. And we just need a new way of working. We need to speed up construction. We need to reduce the cost of construction. We need to improve the quality of construction. We need to reduce the amount of CO2 that construction is producing. So that is the challenge, and in the mind of everybody studying this at the World Economic Forum, technology is part of that solution. I mentioned this report before, but it's really worth reading. The Boston Consulting Group, The Transformative Power of BIM, for those who like reading reports. This is also a great report from McKinsey in 2017, which talks about productivity in the construction industry. As I mentioned, we have a productivity challenge in that we haven't been able to increase productivity over the last 40 years. McKinsey looked at all the different economic sectors and ranked them in terms of how digitized they were, and construction came in second last to fishing or hunting, I think it was. So that's incredible to me, because most of us are using computers on a day-to-day basis in our work, and yet we've come in so low in the rankings of digitization. And one of the main reasons is that even though we're using technologies for many years, at the end of the day we print everything off, and the exchange of information between all the parties is through paper-based documents. So we've got to learn to eliminate the paper exchange and work with digital data. This is also a European issue. The European Commission realized that Europe, in the global context, has a challenge in that our labor rates in Europe are much higher than other parts of the world. And one way to deal with that is to become more efficient and more productive. And so with that in mind, the European Commission have upgraded the procurement regulations in 2014. They've assembled a BIM task group, and they've prepared a handbook for public procuring authorities all across Europe on how to use building information modeling for public procurement. I'm doing a lot of work with the new digital deal to promote digitization in all sectors, not just construction, but obviously construction would fall into that. They've set up a standards group to look at the BIM standards and produce, where necessary, new standards to help the industry. And then in Ireland, the Government Construction Contracts Committee under Department of Public Expenditure Reform announced in late 2017 that they were going to implement a BIM mandate on all public projects starting in 2019 and phasing in over a 3-year period, so 2019 to 2021. starting with complex projects and then medium projects and simple projects. So sometime in the next 2 years, you can expect to see BIM becoming mandatory on all public procurement projects, including social housing, schools, hospitals, primary care, roads, etc. Enterprise Ireland set up a group called the National BIM Council, which was a mixture of public procurement officials and industry leaders to prepare a strategy document for the government called the Roadmap to Digital Transition for Ireland's construction industry. It's really worth reading that document. And the National Standards Authority of Ireland have set up a technical mirror committee to monitor the work that's happening at ISO and CEN, which are the international and European standardization bodies, to reflect that work in Ireland's standardization. And if you haven't come across this organization, I'd highly recommend it. CETA, the Construction IT Alliance, is a not-for-profit network organization that for the last 20 years has been promoting the use of ICT in construction and producing a lot of excellent research and case studies, events, networking events, information events. So it's a good group to participate in and follow if you're interested in the subject of digitization of the construction industry. But at the end of the day, it comes down to your own career, your own business, and what are you going to do about this digitization thing. And I took this image out of the roadmap for digital transition of Ireland's construction sector because it maps out a journey from to 2021 with specific targets in mind, a 20% reduction in project delivery time, a 20% reduction in capital costs for projects, and with this newfound digital capability within businesses to use that capability to export products and services outside of Ireland. So slightly less ambitious targets than the UK strategy, but ambitious nonetheless. And I think every person and every business needs to think about what their role is on this journey. What the roadmap identified is 4 key pillars in achieving a digital transition. One is strong leadership. So having leaders within the organization who understand the need to digitize, the need to follow standards that are already there. So there's no need to invent standards. The standards are already existing. You just need to use them. The need to train and educate people and upskill people. That's a big one because even though people have been using computers for the last 20, 30 years, as I said, we still rely heavily on a paper-based exchange of information and communication. So exchanging digital data is something that's very new to a lot of people. And then we need to investigate better ways of procurement that allow for these digital models to be constructed before we try and execute the work on site. Current procurement models make that difficult. Not impossible, but it makes it difficult. Big question is, how do we get from this analog model of using paper-based documentation to a digital model of working for our projects, for our businesses, for our industry? Unfortunately, the answer isn't just to go and buy some software. Of course, the technology piece is important. We are talking about digital processes and software is required, but probably as important or more important, we need to get all the people that contribute to a project and to the work we do in our businesses to begin to think in this digital way and to produce and exchange information through a digital process. So we need capable people who are willing to come together, to work together, to collaborate, to follow defined processes, to follow standards, and take responsibility for the work they do. So really it comes down to each individual listening to this lecture that you need to analyze what is your role within the project, within the business, what are you producing, how are you exchanging that information with other people so that they can, in a way that they could use it. If you use that finger that's on the screen to print information and exchange it using paper, then unfortunately you're part of the problem. You need to find out how to work with digital information. I want to talk a little bit about standards, because standards are the reason things work. A lot of people feel standards are there just as a sort of added burden, but actually working in standardized ways that you can understand and do over and over again is the reason things work, and things work well. And a really good example of that we've all probably experienced is the travel industry. So it's amazing to think that today, I mean, you can think of going on a holiday somewhere, you can go online, you can search for that place, and almost immediately you are presented with information about various options of where you can stay, what rooms are available, how many people are looking in that room. You can make a choice, you can make a booking, you can go and search for a flight to that destination, and almost immediately you're given 6 or 7 options of flights that are available, costs. You can put in your credit card details and confirm your booking. I mean, if you think about the complexity of that you're interacting with the database of an airline industry and reserving a seat, and it's incredible. The same with hiring a car. You can go and look at various options, pick one, put in your details, and have a car ready when you arrive at the airport. If you've used something like TripAdvisor, this an amazing resource where the people that are traveling to these destinations themselves are contributing information about restaurants, places to go, things to see, and this is being served up to everyone, just making the whole travel experience incredible. And it's not that long ago, if you think about it, the only way to book a flight was to go queue in a supermarket for 2 or 3 hours, waiting to speak to somebody who then had to talk you through these options. And now you can do this in a couple of minutes, sitting by yourself without any training. So behind all this experience on the travel industry is standards. The information that makes up the way this industry functions now is all standardized and around web standards or HTML standards. So the industry has come together and agreed to share their information through these platforms and portals in a common way, and that's what contributes to the enormous growth within the travel industry. So, and we've all experienced this. We've experienced the digitization of the travel industry, in our lifetimes in the last 10 years. So we know how it works in other sectors. So we just need to figure out how to do that for the construction sector. So that's what we're going to talk about now: building information standards. I took this quote out of the roadmap for the digital transition of Ireland's construction industry, because it describes a vision for our industry, which I think is fantastic. It describes a highly efficient, digitized planning, design, building control, real estate, property sector, which will depend on having highly standardized machine readable data, and that there will be a common agreement amongst all the stakeholders that participate in this industry on how to describe elements of buildings or infrastructure from the macro level right down to the building product level in a common data language. and that this standard would be open and vendor neutral and in line with best international practice. So just that paragraph really describes a vision for our sector where we're not all going off in different directions and doing different things and making it difficult for each other, but we're all operating through a common way of describing buildings. And I think the key parts there are the machine readable data. So standards are consensus agreements amongst people within the construction sector. So we've got to begin to use standards. Standards promote operational excellence, and the good thing for us in Ireland anyway is we don't have to invent any of these standards. So these standards already exist for all these different functions within our sector. And it's interesting to see in this diagram that information management is central to other management standards like asset management or project management and even organizational or quality management, ISO 9000. So in other words, you're not going to do project management without having good information management in place. You're not going to do organizational or quality management without having good information management in place. And the standard for information management is already there. So ISO 19650 parts 1 and 2 have already been published. They've been adopted by the European Standardization Organization, which means they are Irish standards because Ireland, as a member state of the EU, has to adopt these standards. And parts 3, 4, and 5 are still under development and should be released either later this year or early next year. But dealing with the operations piece and more specific data exchanges. So in the short term, those we still use the UK standards, but those will become ISO standards shortly. And as I said, standards already exist for asset management, ISO 55000, for project management, ISO 21500, ISO 9000, even environmental management or health and safety management, facilities management. None of these things are going to work without good information in the middle. So these are the relevant standards to consider. When you think about BIM, I think it's really important to understand that there's two pieces to it. There's the way of doing things. So building information modeling is a verb, it's a thing you do. So it's a process. And so you need a standard that describes that process. And then at the end of the process, you do deliver a building information model. So that's a noun, it's a thing, it's a deliverable. So you also need standards that define the thing, the deliverable. So it's important to understand that these two pieces to it. In terms of the process, we've had standards for many years. So BS 1192 originally started in 1998. It was upgraded in 2007 as a standard for the collaborative production and management of architectural engineering and construction information. And in 2013 we got PAS 1192 Part 2, which dealt with the information management using BIM during the capital delivery phase. And so these standards are available. The first two have been superseded now by ISO 19650. So those are already international, European, and Irish standards. And as I said, the others will be coming along. The last one there is also really fascinating, BS 8536. Which is a standard for what's called soft landings. It's really a process of incorporating someone in the design process that is considering the operations and performance of the building beyond the capital delivery phase, and also keeping the delivery team involved for 3 years after handover to carry out post-occupancy evaluations. So people can be trained on how to use the facility or the infrastructure properly, and learnings can be taken from each project and fed back into the next project. So it's actually part of the BIM process, which is not often talked about, and that standard isn't being used very often, unfortunately, but it's a fascinating, when you read it, it's a fascinating approach to design, which is taking facilities management and occupation and performance of buildings in mind. In terms of the deliverable, the actual thing, the information, the way the information is structured, and the classifications, and the processes and delivery of data, ISO standards already exist for those, and those standards have been, as I said, adopted by the European Standardization Group, which means that Ireland has had to adopt those as Irish standards. So we have all these things in place. As I mentioned, ISO 19650 is progressively being developed, but the first two parts have already been adopted. The operational data that needs to be handed over at the end of construction, COBE, the Construction Operations Building Information Exchange, is a model view definition defined under the ISO standard, and we'll talk more about that. There's a standard for the data security that's in place. At the moment, it's a UK standard. It's being developed into an ISO standard, and there's a standard for delivering structured health and safety information using BIM, PAS 1192 Part 6. So if you're involved in the health and safety project supervisor design process or project supervisor construction stage, that would be relevant to yourselves. And as I mentioned earlier, all of these standards are really being driven at the highest level around asset management, because you can't effectively manage assets without good information. And so ISO 55000 is a standard for asset management. So that's an overview of the different standards that are relevant. People often ask, why do we need to standardize? And why do we need to do things in a common way? Well, the big reason is that we need to become more productive. We need to find enormous efficiencies in the way we do things, and we can't do that if we're starting each project with a blank sheet of paper and reinventing the way of doing it over and over again, or working in different ways to the people we collaborate with. Okay, so the effort that you put in to produce information once needs to be leveraged multiple times across the project or across multiple projects. And BIM, or Building Information Modeling, and this idea of focusing everything around the object allows us to do that, because the objects become digital containers of structured, standardized information that can be transferred from project to project, within organizations, across organizations, and even the knowledge that people are, that when they're working on projects, that they're embedding into these digital objects is captured and is transferable. So organizations need to begin to think about this in terms of structuring libraries within their organization, so that when people produce something, that it's put into a library and it can be used multiple times, and even groups of objects. So if you look at a bathroom or kitchen, so this 52 could be 50 different objects within a kitchen. There's no need to redraw those things every time. You just bring the whole group of objects into a project. Okay, you might need to rearrange them, but you've leveraged the effort that you've put in once multiple times. Even building types. If there's a particular type of building that you work on over and over again, whether those are data centers or schools or hospitals, the effort that you've put into the first project can be leveraged and reused if you use a standardized approach on multiple projects. And having predefined templates within your organization. So all of these are just some ideas of how you could take the effort that you've putting in into a digital object and leverage that many times over, including processes, so the way you check models or the way you build up cost catalogs, etc. And the common data environment we'll discuss in a bit more detail. So those are just some practical examples of the application of standards and standardizing your data around digital objects. From a project management point of view, and how you get a project to leverage this approach, um, it is a process. So that process is described in ISO 19650 in detail of the things you need to do. But to try and summarize it for you just in a graphic, so the standard should be at the center. It's a specification of how to manage information through the different phases of a project in the capital delivery phase. The first thing I would say is when you're assembling a team as a project manager on behalf of your client, is that you choose the right people. So don't choose people just because they offer you the cheapest deal. Choose people that have the capability to contribute to the project in this digital way that we're describing. So ask some basic questions at the earliest stages about people's capability to follow the standard, the capability to use these digital tools, and choose the right team that's going to help the project, not hinder the project. The second thing is make sure that a clear requirement of the information that's required is set out, and it's called the Employers Exchange Information Requirement, or EIR. It's a document that's put together at the earlier stages that describes what information needs to be exchanged at various stages within the project, and that's something that people need to respond to formally. So that document is really important that it's put together. And what I would say is many clients don't know how to write these documents, and so as a project manager you might need to assist them, because if they don't put that document in place, then obviously people don't have anything to respond to. The next important step as a project manager is you need to make sure that some commercial agreements are put in place. So the first one there is every company that's going to contribute to either the design or the construction needs to have appended to their appointment or their contract a BIM protocol. A BIM protocol is a standard form that works with standard forms of contracts or standard appointments to basically, it's the legal requirements around BIM, such as roles and responsibilities, etc. So we'll talk more about that in a coming slide. But as a project manager, you need to make sure that that occurs. You need to make sure somebody is put in charge to manage the information process at the different stages. So normally the lead designer on a project would be the project information manager for design stage, and the main contractor would be the project information manager for the construction stage. And that's not new, because the lead designer always had a function to coordinate design information, and the main contractor always had a function to coordinate construction information. But you're just formalizing that in a specific role related to information management, and that appointment of that role needs to take place. There's some PI insurance issues to deal with. There's a guidance note from the Construction Industry Council that basically says that if everybody who carries PI or has design responsibility should let the insurance company know that they're participating on a BIM project. The next one there is you should assemble with your client a digital plan of work that describes how this digital model is going to come together over time. So you wouldn't attempt to build a physical building without a plan of work in place, and in the same way you shouldn't attempt to try and construct a digital building without a plan of work in place. And very importantly there, the digital building must be constructed before the physical building, so that you can test and resolve issues within this digital environment before you try and execute that work on site. Okay. In the UK, the government paid the National Building Specification to develop a free online tool to put these plans of work together, which people are welcome to use, or you can use Excel or other tools, whatever you like. Then from the supply side, and by the supply side, I mean both designers and contractors, when tendering on projects, their response to the employer's exchange information requirement is what's called a BIM execution plan. So that's their formal response. Those two documents are almost mirrors of each other, because the first one is the client or the employer asking, describing what they want as an outcome. The designers and the contractors are responding of how they're going to do it, but they're responding, like for like to the EIR. So that's a formal response. It's a document. There's a lighter version at tender stage called the pre-contract BIM execution plan, which would also then include some detailed BIM capability assessments describing their IT infrastructure, their HR infrastructure. Once people get appointed to the project, then they would contribute to what's called the post-contract BIM execution plan, and that's again a formal document which is then managed by the project information manager for that stage. So if it's for design stage, the lead designer, or if it's construction stage, the main contractor. And all the parties will be contributing to that document. So it's again the formal response of the supply side to the client's requirements. For the project, a common data environment has to be put in place. So it's a digital repository where all the digital files will be held and managed, and we'll describe that in more detail. And at the end of this process, there will be a deliverable. In other words, the project team will deliver a digital version of the building, which will include operational data, or COBie. So we'll talk about that in a bit more detail. It'll make sure that all the digital objects are classified using Uniclass in our instance, and it may include this soft landings appointment where the team are kept on for 3 years after the handover to do post-occupancy evaluations. But there is a deliverable, and that's the digital version of the building. So as a project manager, you need to understand this process. It's not your job to do all these things, but it is your job as a project manager to make sure all these things get done and are implemented at the right time, because if they're left out, or they'll have some impact on the overall process. So very quickly on the commercial and legal issues that were called up in that previous slide. So there's a standard document. The CIC BIM protocol is the legal instrument to implement BIM, covering issues such as roles and responsibilities, rights, copyrights, licenses to use data, exclusions of liability, limits of liability, etc. So this document needs to be appended to each appointment and contract, and then there's 3 appendices which need to be completed that are project specific. As I said, there's a standard scope of service for information management. This particular document needs to be implemented to the lead designer for design stage and the main contractor for construction stage, so that they take on that role. And then from the PI insurance, there's a guidance document. As a project manager, you need to ensure that everybody is aware of this guidance and make sure that every company that's participating that has design responsibility and carries PI insurance have informed their insurance companies, and it'd be useful to get confirmation of that so you can make sure everybody, the project is covered from an insurance point of view. In terms of all the other documents that need to be produced at various times, such as EIRs and BEPs and capability assessments, etc., The Royal Institute of Architects of Ireland have produced a useful BIM pack of advice notes and guidance that's available as a starting point. What I would say about this is at the moment it still refers to the previous UK standard, PAS 1192. So, when you're preparing these documents for the project, you'll need to upgrade that to the ISO 19650 standard. But at least there's a good starting point and some good guidance and notes on what needs to happen at the various stages. And just very quickly looking at the contents of an employer's exchange information requirement, but these are the types of subheadings within the document that need to be fleshed out. And as I said, the RAI has guidance on how to do that. So I'm not going to go into too much detail, but you can see you're dealing with information management issues, commercial management issues, competency assessment issues, and if you're assessing an EIR or helping your clients to prepare an EIR, these are the items that you need to discuss and document. And similarly, the BIM execution plan, the pre-contract version, if you look at the headings here, they're almost exactly the same as the EIR. In other words, the supply side, the designers and the contractors are responding to that EIR, to the relevant sections of the EIR, and that's why they have a similar structure. Once they get appointed, obviously then they'll flesh out that BIM execution plan to in more detail to cover their standards, methods and procedures, and get specific about various IT solutions they're going to be using, and start developing out their information delivery plans, etc. Coming back to this slide which we discussed earlier, because when we try and manage this process, we need to understand that for every component that is going into the building, every product and every system, that there will be three things. There will be an object within a model that represents that thing. There will be a set of data properties or attributes related to that object, and there will be a set of documentation in relation to that object. And with that in mind, to effectively manage the information on the project, we need two lists. The first list we need, which is called the responsibility matrix, or what used to be called the model production delivery table, is effectively a list of all the elements, systems and products types that are going to make up the physical building. So it's a long list of things, and for each object type we've got to define how much graphical detail we want in the three-dimensional object, how much non-graphical information we need at each stage of the project, and who's responsible for that thing at the different stages. So typically the designers would be responsible for those during the design stage, from stages 1 to 4, and then the contractors and subcontractors would be responsible from stages 5 and 6 up to handover. So that's one list, and I like to think of it like an input list, like what are we going to put into this model or this building. But the other list we need to make is what are we going to get out of this model. So all the different files and documents that are going to be produced and submitted to this common data environment. And these files will contain various things, but there'll be model files, drawing files, schedules, specifications, reports, bills of quantities, minutes, technical data. So everything about the project is stored within the common data environment. And the second list, the master information delivery plan, is a long list of all the files that need to produce. So I like to think of that as the output list, and the one list informs the other list. So going back to the previous image, for everything that we put into the building, there will be these three types of data, model, geometry, non-graphical information, and a list of documentation related to those things. So they are connected. And with these two lists in place, we can begin to manage progress on the project of how everybody is doing. So we can check the first list to make sure that those elements that we've specified within the responsibility matrix exist within the various models. We can also begin to check that how far the documentation is and all the files are progressing within the common data environment. So to effectively manage this information, these two lists are incredibly. Let's talk about in a little bit more detail about the common data environment, which was originally specified in BS 1192 and now in ISO 19650. It's described as a single source of truth of all the information on the project. So a repository of all the information, a place to collect and manage and disseminate that information with other people. So people should no longer be sharing information through emails or other sorts of exchanges. Basically, people share information through the common data environment. It deals with a couple of things. Number one is every file that goes to the common data environment has to be named in a particular way, which we'll discuss. It also describes how objects and layers within files get named, and it describes an approval workflow in order to manage the information carefully so it doesn't become just a dumping ground of inaccurate or incorrect information. It is effectively the collection of the three types of data: the documentation, the non-graphical data, the graphical data. It progressively develops over the different project stages. There's key data drop points at the end of each stage, obviously to check and sign off information for that stage before we progress to the next stage. The ISO 19650 Part 2 deals with the capital delivery phases, stages 1 to 6, and ISO 19650 Part 3, which should be out by the end of this year, but at the moment it's still PAS 1192 Part 3, deals with the operational phase of managing all that information within the common data environment. The standard doesn't say that it should be a single system, so it's quite likely that it'll be a number of systems. It's often the case that the design team would agree on a system to use collectively through the design stages, and then they'll hand off information to the contractor, who would manage a different environment for the contractors and subcontractors during the construction stage, and then they'd hand off everything to the building owner or operator at handover stage. So there are particular points where information gets transferred in one way or another. Of course, it could be a single system across all those stages, but it's very unlikely because design teams and construction teams have different needs, and so does the operator have different needs. But obviously, the information has to be consistent across all those stages. You don't have to repurpose information. So everybody needs to follow the standard in a consistent way across all those stages and across all those systems. A very important part of the way in which the common data environment functions is the file naming. And it's like a license plate on a car, which is, in the way it works, is a series of codes that tell you certain things about that car, like what country it's in, what year it was registered, which county it was registered in, a unique number for each car, so that when cars are driving by, you can gather this information without stopping the car and sort of opening the bonnet and looking inside. In the same way, every file that goes into the common data environment has a unique set of codes that describe what's in the file or the container, so that people can understand what's there without having to open the file, and also computers can manage those files based on those codes. So The set of codes defined in the UK Annex of ISO 19650 deal with things like the project it relates to, the company that originated the file, the volume or system the file relates to, the level if it's a vertical building, or location if it's a horizontal piece of infrastructure like a road or railway, the type of document it is, whether it's a model or a drawing or a set of minutes or a report or a schedule, the discipline it relates to. Also, each file would have a unique number, and the last two are pretty important. Each file would have a status code telling you why it was provided. So what can you use it for? You know, is it just for information, or is it for coordination, or is it for tendering purposes, or is it issued for construction, or is it the final construction record? And finally, the revision of each file. So each file name looks something like what you see on the screen there, and at first people think that's a bit daunting, but as like the license plate in a car, once you understand how the codes work, it's incredibly easy to find stuff when you're looking for it and understand what's in those files without having to open them, which saves an enormous amount of time for everybody. The common data environment also deals with the management of those files and making sure that the files go through a rigorous checking and approval process. So files would start in a work in progress state, where people are working on them and developing them internally within their own organization before sharing them outside. When you want to share something outside of your own organization, it has to be officially approved by a manager. So whoever's the designated task delivery manager or task team information manager has to put their stamp of approval, if you like, on that file, saying that it's allowed to be shared outside the organization, and that's recorded. So anybody else who discovers a file in the shared state knows already that it's been approved and checked by a manager. If you're referencing files within your own environment, xrefing files, then obviously you take those from the shared state of another organization and use those as a reference in developing your design information. Finally, at the end of each work stage within the process, you want to get final sign-off from the client and acceptance from the employer. The project information manager would assemble all the relevant documents to be shared with the client, and then there'll be a second approval by the client representative who formally accepts those files to be in a published state. And finally, at the end of construction, when the final record is the building is constructed, the client representative would also verify that what has been constructed is in accordance with the documents that were published, and everything will be archived. Of course, along the way, anything that gets rejected or not approved also is submitted to the archive for historical record in case there's a dispute later. So that's the management process, and it's very clear, and there's a double approval system to everything that's finally published for action, and hopefully that will ensure the quality of information. The other standard we'll talk about is BS 1192 Part 4, which is called COBE. COBE stands for the Construction Operations Building Information Exchange, and it's just important to understand what that is. It's a set of non-graphical data at the handover to be transferred to computerized facilities and maintenance systems. So that's its purpose. It's a set of the data, not all of the data for constructing a building, but it's the data to maintain and operate a building that gets transferred to facilities maintenance systems. some of the information is produced by the designers, so they are obviously determining the floors and the spaces and the equipment layout and the specific design performance of information. And some of it is produced by the contractors, subcontractors, and suppliers who would give the more detailed actual equipment information and serial numbers, warranties, etc. So the way it's delivered and presented is through an XML format, which like an Excel spreadsheet, which effectively is a series of worksheets which are lists. It's just, so it's not that complicated. It's a list of information about all the floors, a list of information about all the spaces, a list of information about all the zones or departments, a list of information about all the types of objects and the spare parts and maintenance tasks related to those, how those are connected to various systems that make up the building, the contacts, a list of all the contacts of people involved in providing either information or the equipment, a list of all the relevant documents, etc. So it's just a series of lists in a structured format that can be handed over at the end of construction, and then the operators can take that information and bring it into a computerized facilities or maintenance system without too much retyping of information. That's its purpose. The idea is not that people have to type out those lists. You, in the BIM process, as we've described throughout this lecture, is you constructing this digital model of objects that represent real-life components, and within those objects there's information about what they are, and part of that information is extracted into these various lists of information. So as I said earlier, some of the information will come from product suppliers and product manufacturers, and they may not be using a 3D process themselves, but what you can do is issue them with a structured electronic product data template in Excel format or equivalent, and with the right attributes that they need to populate with the right values, and then you can import it, because it's in the same structure, you can import that information into the final Kobe deliverable, or using tools like Excel Link or Dynamo, you can move those attributes into the objects within the model, if you like, to close the loop. So, for the most part, people aren't typing these lists. The information is already there within the models to generate notes on drawings and various other schedules. So it's just presenting that information in a particular way. So that's part 4 of the standard. It's looking at the overall asset information model over its life cycle, I think is important, and this looks particularly at the operational phase of assets. But if we look at these 3 types of data, the capital delivery phase is a very short period in an asset's life cycle. Within that period, there's a lot of time and effort put into gathering and structuring and presenting these 3 types of information to a client. And if it's handed over at the end in a paper-based format, then this happens. The information will begin to degrade and deplete because it's in a static format and can't be maintained, and probably end up getting mixed up and lost. And so its usefulness, for all that effort and all that money put in producing the information, will become less and less valuable over time. So obviously, from a building owner's point of view or an asset manager's point of view, that's less than ideal. And so PAS 1192 Part 3, or what will become ISO 19650 Part 3, describes a process for managing the information in the operational phase, which is a much bigger phase of the asset's life cycle. And the way that's done is, first, the organization, if they maintain a number of assets, will have an overall organizational information strategy that defines their requirements, and then they'll look at each particular asset within their portfolio and devise a specific asset information requirement for those those assets. And then if there's any capital works projects related to those assets, whether it's a fit out or rework or renovation or even an extension or rebuild, then the new capital project would get a new employer's information exchange requirement prepared, so that any work that happens continuously feeds into a digital strategy for these three types of information. So that's what PAS 1192 Part 3 deals with. You can implement this standard on any asset at any time. So all the existing buildings that asset managers have within their portfolio, they could implement this strategy straight away. Obviously, any information that's in paper format will have to be converted over time into digital format for this new digital strategy, but that can be done. The cost of implementing this strategy is obviously going to grow the longer you leave it. So there's an argument when you're a building owner or developer looking at this to say, well, if we move that line of implementing a strategy right to the beginning before anybody's done any work, well, then there's going to be no cost, because people still have to produce the information as part of the capital works, and as long as that information is produced in a digital way and presented in a digital way, then there's going to be no additional cost. But if you leave it to later, then any information that's produced outside of these standards will have to be reproduced or repurposed. Also, the value that having access to digital structured information would bring to the asset in terms of anything you have to do in relation to that asset over its life cycle, in terms of able to query the information, find the information quickly, maintain the information, is obviously highest the earlier you move that line back to the left in the asset's life cycle. So again, that makes the argument to begin the strategy at the very early stages of projects, if you can. But if the asset's already constructed, it doesn't mean you can't implement the strategy. It just means it's gonna cost you something, and it's the value might be slightly less. So that's what PAS 1192 Part 3 or ISO 19650 Part 3 covers. So in the same way, it looks in a little bit more detail. It looks at the asset management activities related to any asset, whether it's a building or a bridge or a road. It then questions what information is required to carry out those activities, and that information will reside in the digital asset information model, which again is the collection of graphical data, non-graphical data, and documents held in the published area of the common data environment. Okay. It also sets out certain activities which potentially will change the information, and it sets a trigger against those. So these activities listed here, such as changes in occupation, maintenance tasks, minor works, fit outs, major works, these types of activities will potentially result in a change in the physical building, and therefore will require a change in the information model. And in the same way, the common data environment is updated. Work is taken out of the asset information model, worked on, updated, shared, checked, finally approved, shared with the client, who then authorizes that to be submitted back to the published version of the asset information model, and anything that gets changed gets archived and put back for historical purposes. But if you carry out this process every time something happens to the building that could change the information, that means the asset information model will always be up to date, and it will always reflect what's physically out there on site. And if you do that, if you can make sure that you're maintaining the asset information model in the same way you're maintaining the physical building. It means you have an accurate digital resource of information that you can connect to other enterprise systems such as financial systems, ERP systems, building management systems, etc., that would contribute to their functioning as well. So you can see that the common data environment has a very important role to play both in the capital delivery phase of projects, but also the operational phase, and it has some really important work that it has to do. It has to maintain this central repository of information. It's got to deal with the three types of information: the graphical data, the non-graphical data, all the documentation. It's got to manage these workflows that we're describing here. You can't expect human beings to remember to manage these things manually. They will forget, and if they forget, then the information gets out of date. So you need a system that is controlling this for you and managing the responsibilities, the approvals, maintaining all the historical data and the audit trail in case there's ever a dispute or a problem. And since this data will be quite sensitive to the building and the building owners, that have to be able to control who has access to it and the security around that. So we've discussed a lot of things today. It's been an intense overview of all the different standards, and we briefly touched on many subjects, but some of these subjects different people will have to get into more depth on. So there's just a short list of some of the things we touched on: the standards, the ability to interact and review these models, the ability to author these models if you are a designer, the collaboration tools, the coordination and clash detection, the sequencing and planning, the costing and quantity takeoffs, structural analysis, energy analysis, site setting out, surveying, engineering, safety, quality control, document control, delivering COBE. So all of these topics, I think when you look at a business, you need to decide where you are in the business and which of these are directly relevant to you, which do you just need to know a little bit about so you can have a conversation as a project manager with other people and make sure they're doing the things they need to do, and which do you need to know in more detail. And so you need a sort of an education plan for everybody on the project or in the business that make sure that people have the right level of skill. So there's a lot to learn outside of this lecture. There's lots of different ways to learn. The purpose of learning is to acquire the skills and knowledge that are required, so that you can develop competencies in these different areas. In terms of ways of learning, obviously there's less formal social media and community sharing learning, such as YouTube. There's self-learning. You can do formal courses online. You can do webinars. You can undertake third level education at undergrad, postgrad level, master's level. So it's really to figure out what works for you. In terms of where this is all going, the digital future of construction and the construction and property sector, there's already some fascinating technologies emerging and trends that are occurring that will describe the environment in a few years' time. So as a project manager, you need to be aware of these things, that these are coming, and see what you need to find out about these different technologies, such as laser scanning, and converting laser scans to BIM, surveying, setting out on site using the model instead of traditional coordinate systems, the 3D printing and digital fabrication. So there's a big move to offsite and modular construction, and using new forms of fabrication to build buildings or components of buildings, or virtual reality and augmented reality as ways to interact with these digital models at different times. Virtual reality is a way to interact with models before the building exists. Augmented reality is to overlay the models with what's existing at the moment, to do comparisons. Uh, there's the use of drones and robotics is increasing in the construction industry, and equipment and elements of buildings are becoming more intelligent by having connected sensors that are connected to internet networks and giving feedback all the time. So the Internet of Things is growing all the time. There are trends in how people are using technologies to design buildings, so computational design, generative design, doing more and more calculations and optioneering to come up with better and better solutions, um, new forms of manufacture. So construction in general is moving more towards a manufacturing model with offsite construction, modular construction, lean principles. Lean is something that has come out of the manufacturing, but it's a methodology for reducing waste, and those principles are being applied to the design and construction world. So lean design, lean construction, and then new forms of procurement. So there's trends in moving away from the traditional adversarial sort of design, bid, build models to more integrated partnering or alliancing models of procurement. So these are things you need to begin to become aware of, understand, see where they're going, and keep ahead of the curve. And the big question to ask as a project manager is, what is your role in this digital future of construction? So, so after that, BIM for project managers, just the kinds of questions I think you should be able to answer as a project manager when you're helping your clients is many clients won't understand what BIM is and why it's needed, and you need to be able to convey that message, to talk about why it's relevant to the project, why it's important, what it's going to bring. Also to give your clients some idea of what's happening globally, in Europe, in Ireland, and just know as how can you as a project manager ensure that people are doing this properly and they're not practicing pseudo BIM. 5 key questions I think every project manager should be asking all the time is, all the documentation as set out in the standards in place? Because this documentation isn't just for the sake of it. These are tools to allow certain things to happen. So the pre-qualification questionnaires is a tool to make sure that you're getting the right people on the job. The exchange information requirement is a tool to communicate formally the requirements of the project to anybody who's participating. The BIM protocol is a tool a legal instrument to allow BIM to legally work with contracts and appointments, PI insurance. The project information manager is a key role, both design stage and construction stage, so that somebody feels ultimately responsible. The project implementation plans and an assessment of the BIM capabilities of all the participants, and dealing with any shortfalls in skills is really important to mitigate risks. The task information and master information delivery plan, as I said, is a tool to manage all the information files that are going into the common data environment and to track progress against those. The BIM execution plan is a formal response from the supply chain, from the designers and the contractors, that can be assessed. So again, these are really important project management tools. The common data environment, as we said, is this central repository of information that is managed carefully, where all the files are named in a particular way and have been through a robust approval process. The responsibility matrix or the model production delivery table is a tool to monitor what's going into the building, all the objects, and the digital planner work is a tool to assign responsibility and decide when during the different phases of the project these things are needed and to what level of information or level of detail they're required. So these are all very important parts of the BIM process, and it's the role of the project manager to make sure that these things are happening. Also, project managers should make sure that all the participants in a project are aware of their role in this process, because of the way the construction industry is structured. A typical project could have up to 100 different companies or people involved at different times, and the requirements can get easily lost within that sort of fragmented structure. And I think one of the roles of project managers is to monitor and make sure everybody is aware of their participation and what's required of them. Is project information being generated and delivered through a suitable format, so not being printed off and put in a box, but being delivered as a digital file that can be used and leveraged by other people? Is this coordination of the federated model taking place at the regular design coordination meetings, and are the issues being resolved in the digital environment long before those become real issues on site? And is the information being regularly checked for compliance with the employer's information requirements? So project managers have a very important role, in my opinion, on projects within the BIM process. It's not their job to do everything, of course. Those jobs are assigned to various other people, but as a project manager, you have an overview and you have a responsibility to your clients to make sure these things are implemented properly, and that BIM delivers value. It delivers time savings, it delivers cost savings, and it delivers better quality for your clients, and that's ultimately what your clients are interested in. So I hope that lecture was useful and helpful to all the project managers listening, or future project managers. And so I suppose just to end off is say a little bit about our own company. We're a BIM consultancy practice. Our role is to assist any participants on projects or companies to participate in this digital process through either advice or consultancy. We do offer some production support if people need it to close any skill gaps or production resource problems on projects. We offer training in various software and processes and support. Our job is not to do other people's work for them, but rather to help other people do their work in a more collaborative and digital way. So we kind of see ourselves as the glue that brings us all together. So thank you very much for your time, and hope everybody will participate in the digital future of construction. Thank you.